Yeah, good afternoon, everyone. Hello. Hello, is it audible?
Audible, sir.
Yeah, yeah. Shall we start the session?
Yes, sir.
Yes, sir.
Okay. Now, in continuation of last class, can anyone tell? Almost most of the people are completed. I think Ash can tell heap sort, right? With heap and max heap. I given the max heap explanation. I think most of the people are done mini heap. Still, any doubts in mini heap and sorting heap sort? Any doubts? Hello.
No, sir.
No doubt, sir.
Yeah, everyone is done. Yeah, good, good. Now today we are going to learn. Today we are going to learn external sorting. Here, before discussion of external sorting, first of all, we must know the merge sort. Even we discussed about a merge sort in the last class, correct?
Yes,
Hello,
sir.
Yes, sir.
are you there? I'm asking merge sort. In the last session, we discussed about merge sort. Yeah, tell me, anyone, what is merge sort? Hello, what is the logic behind of merge sort?
It follows the divide and conquer rule.
Alustan? Hello.
It follows divide and conquer also.
Yeah, it follows the divide and conquer rule. Okay, okay. But I'm asking exactly uh, what is the how the process will done.
First, it breakdowns into small subunits
Hello.
and then again,
What is
The
the
list,
process?
the list will be breakdown into several sublists.
Explain someone what is the process of merge sort.
it will
Hello.
repeatedly break down the list into a sublist which will consist of single element. And then after
Yeah.
that, we will compare and then make into a single list.
Yes. Yes. Right. Yes. That is fine. Yeah. That merge sort is going to help a lot for your external sorting. Why external sorting is required? A simple mechanism. When you are going to perform a sorting mechanism, only certain amount of data. For example, maybe the data is maybe 1,000 elements or 2,000 elements or lakh elements. Okay, not a problem. But always this computation process will be done in primary or secondary memory. This computational task will be done. This swapping or the comparisons will be done in the primary memory or secondary memory. Hello. This process will be done in the primary memory or secondary memory. Hello, my question is very clear. Any operation, if you want to perform, that will be done in the primary memory or secondary memory.
Primary memory.
Primary memory only. So that here the data is huge. Maybe machines are using only 2 GB or 4 GB or 5 GB, or maybe sometimes 8 GB. But sometimes my data is huge. My data is huge, very big data. So that the primary memory is not sufficient. Are you following? Maybe the data is big data, maybe 20 GB or 50 GB, 100 GB data is there. In that 100 GB data, I need to uh, sort. Now, at a time I'm going to keep with primary memory. Total memory is going to occupied by primary memory, but it is not sufficient. Yes or no? It is not possible to swap that much memory because my machine is having only 4 GB or 8 GB, but I want to sort 100 GB data. Is it possible? Is this possible?
No, sir.
No. So that what happened? The problem is came because your sorting is not done. Understand what I am telling? Hello.
Yes, sir.
So that what should we do? That is not possible. When the data is bigger, the sorting process cannot be done because hello. Because memory is not sufficient. Hello.
Yeah, yes, sir.
So that we need some external sorting mechanism. Are you clear now why external sorting mechanism is required now? Understood why?
Yes, sir.
Hello? Hello? I am not getting your voice. Hello?
Yes, sir.
Yeah. So we need a external sorting. Then what the external sorting contains? Exactly. The external sorting is nothing but it is going to sort the data with help of the secondary memory. Are you clear? Are you clear?
Yes, sir.
Sir, how external memory will work? How it is going to compare? Simple. Here, the data is divided into number of chunks. For example, my external memory is my data is 100 GB. Now I wanted to sort that 100 GB of data. Here, that 100 GB of data I need to sort. For this, uh, uh, I'm using only 4 GB of primary memory. The sorting mechanism will be done only within the 4 GB of primary memory. but that 100 GB of data, it is not sufficient to sort. So that I need a mechanism. That's why here I need to divide the data into number of 4 GB chunks. Here, first of all, I have to select the first 4 GB chunk and I have to sort it. Then I put it into the buffer. Then again, I need to select the next chunk and again I sort it. Then I need to select third chunk. Then again sort it. Like that, I am doing all the chunks and I am again sorting that data. And finally, again, I am going to again merge. You know the merge sort, how we are using the merge sort technique. Same way you can use the merge. Here, using that, I'm going to arrange merge all the sorted data. Finally, I will get one sorted data. Are you clear?
Yes, sir.
Means just we are using same merge sort mechanism, but the thing is always we have to take that merge sort uh, uh, mechanism for every particular part. Means I'm going to apply same mechanism, divide and conquer policy also here. Understand? Divide and conquer policy. Hello? Understood now? The bigger problem, how we are going to solve any big problem, complex problem? You need to divide. Hello? No one is responding. Respond quickly.
Yes, sir.
Yeah. The same way, here the data is big. That primary memory is not sufficient. So that we need to divide the uh, we need to divide the data into smaller chunks. Yeah, based on that, we are going to divide the data into
Smaller chunk.
different chunks, and that every chunk you need to process and nothing but sort it, and after sorting every chunk again you have to merge these two chunks and again you need to sort. Understand?
Yes, sir.
Yes, sir.
So that mechanism is called as external sorting because we are not doing sorting in the primary memory. We are taking help of the secondary memory, external memory. Correct?
Excuse me, sir.
Yeah, tell me.
You shared a screen, huh?
Hello?
Sir, you shared a
Sir, I have
screen.
not shared a screen. Yes, I have not shared any screen. I am explaining only the introduction. Okay.
Okay, sir. Okay.
Yeah. That is what I am asking. Here, now we are doing the process in where externally with help of external memory. Yes or no?
Yes, sir.
Yes, sir.
Yeah, that's why we are avoiding the problem of sorting the data so that we can solve the large amount of volumes of data sorting mechanism also with help of this external sorting mechanism. Understand? I will show you the mechanism with help of examples. First of all, understand the theory, prerequisite. Are you clear?
Yes, sir.
And for this solving, we have two mechanism, two external sorting mechanism. One is two-way sorting and multi-way sorting mechanism. Hello. Today we are going to finish up this fourth unit with completion of this two-way and multi-way sorting mechanism, external sorting mechanism. I will show you, don't worry. Now understood why, what is the external sorting, why external sorting is required, and how it is going to solve. Everyone is understand?
Yes, sir.
Yes, sir.
Yeah. Now I am going to share the screen of today's presentation. Here, just now I mentioned very clearly. Here, introduction is I told you just now why it is and what is the reason we need to use. My screen is visible now. Is the screen is
Yes, sir.
visible?
Yes,
Yeah,
sir.
yeah. Now, yeah. Now this external sorting. Here, that MedSort is very important. Already I told you. Here, whatever the story I told you, here this is the story you can read. Okay, already I shared these notes. Then please read the things. Whatever I told you just now, everything is mentioned in these notes. Here with high content is there. Please once you go through these notes, then uh, you can understand exactly why this external sorting is required. Clear? Is this clear?
Yes, sir. Clear.
Here we have two simple approaches to solve to external sorting. One is two-way sorting, another one is the multi-way sorting. We will discuss that with some example also. Very important, people are asking. Here, when you want to perform this external sorting, we need to follow these four steps always. Yeah. Now the first step is split the original file into two equal sized run files. Run file is nothing but a chunk, a small amount of data. Are you clear? Is it clear? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Please respond.
Yes, sir.
Now, next step is very simple. I will finish very less time because it is very easy. You can understand mathematical things only. Second, read one block from each run file into the buffer. Yes, you have to read because it is a big file. We cannot store in the primary memory. That's why that chunk, some block of the file means we have to divide the number of blocks. Right, one block you need put it to the buffer. Take the first, third step is take the first record from each input buffer and write a run of the length to output buffer sorted order. The fourth step is that is take the next record from each input buffer and write. Here same thing, we need to perform all this process and every time you need to select and you need to do that. So finally you will get the result. Here this is a two-way. This is two-way external sorting. So I will show you with one example, then you can understand. So this is input. Please clearly observe here. Otherwise, you need to write in notes. Very simple. So this is input. Here two chunks I have taken initially. If you want to take more data, also you can take it. Here, for understanding purpose, I have taken only two chunks. How it is going to sort. Here now this is the two chunks. Here now I am going to sort. Okay, using two way. Already I told you very clearly. The two way. Next multi-way I will show you. Here now. Here, this is the buffer, nothing but external storage. Now, here input. Now, first of all, you need to read this data and create the data, and you need to select the first element of the first chunk and the first element of the second chunk. Now, you must be compare and sort these two elements, put into the first buffer. Here, 20 and 36 comes to first buffer. Are you clear? Are you clear?
Yes, sir.
Yeah. Next again you need to select again first elements 17 and 13. Then you need to sort it. 13 and 17 must be placed into where? Second buffer in the first position. Clear? Clear. Very simple. Yeah, very simple mechanism. That's why you can understand very easily. Clear this?
Yes, sir.
Right. Next 14 and 28. 14 and 28. We have to again sort it and place into the first buffer. Then 14, 28 comes here. Then 15, 23. You sort it. 15, 23 placed in the second buffer. Clear?
Yes, sir, clear.
Yeah. Now same thing again. We need to now this is empty, right? Now. So now from here we need to process again to this position. Your first level is over, one way is over, the second level. This is what second level. Now from here to here you know, do this. So what is that? Here two way. Now here two way is the mechanism. Now here two elements. Here 20, 36 and 13, 17. 20, 36, 13, 17. Then you need to sort it and place into the first buffer. Means what happened? 13, 17, 20, 36. Correct? Yes or no?
Yes, sir.
Yes or no? Clear this? Hello?
Yes, sir, clear.
Hello? Yeah. Now next here 14, 28, 15, 23. 14, 28, 15, 23. You can sort and merge into the second buffer. Yes. Clear this?
Yes,
Clear
sir.
this? Yeah. Now this is what? Exactly two times. That's why it's a two-way. Two-way external sorting. Understand? Understand? Everyone? Hello?
Understood.
Hello? Don't feel this is so much of complexity. Very simple mechanism. Your simple mathematics only. Are you clear?
Yes, sir.
Yes, sir.
Right. Now, same thing I can represent in one diagram. Here, two-way, right? Here, that is what? 3, 4, 6, 2. This is the input data, input file. From this, what happened? Initially, here 3, 4, okay, sorted. 6, 2 sorted to 2, 6. 9, 4 sorted to 4, 9. 8, 7 sorted to 7, 8. 5, 6 sorted to 5, 6 only. 1, 3, 2 asterisk. Now, first pass. Here in this first pass, here the output is like this. Here now, after the second pass, that is what two way. The second pass, what happened? Here 3, 4, 2, 6. What happened? 2, 3 will come, 4, 6 will come. Are you clear? Same mechanism. In another way, I am explaining. Procedure is same, but another way also we can represent for understanding. Is it clear?
Yes, sir.
Yes, sir.
Merging, yeah, merging only. That is what merge are. Now 4, 6. Here, what happened here? 4, 7, 8, 9. 1, 3, 5, 6. 2 asterisks. Then you can merge. Finally, you can get this. This is what two way. two-way sorting mechanism. Are you clear about this two-way external sorting mechanism?
Yes, sir.
Yeah. Here now, next one is the multi-way external sorting mechanism. Okay, multi-way merging, multi-way external sorting mechanism. Here the things are different. Here we have taken only always two input chunks. That's why it's a two-way. Correct?
Yes, sir.
Yes or no? But here in M-way multi-way merging, external sorting, we can take n number of B-way. B-way is nothing but many number. Okay, n number of chunks you can take it at a time. Are you clear? At a time you can take n number of chunks. Are you clear?
Yes, sir.
But in this example, I have taken three-way. That's why in the place of n, I am taking three-way. Means three chunks I am taking. Sometimes you can take 4 chunks, 5 chunks as per the requirement. For easily understanding, I have taken 3 chunks. That's why it is a three-way. That's why it is a multi-way. Okay? Clear? Clear?
Yes, sir.
Hello? Yeah. In this multi-way external sorting mechanism, here 3 chunks I have taken. In that always every time you need to check first element. Only first element you need to compare and select the which is the smallest. Now, what are the elements you have to need to take? First element 5, 6, 12. All these 3 are. Here, which is the smallest here? You compare it. 5, 6, 12. Which is the smallest? Like that, if you have 10 way, then you need to take 10 chunks and first element of all the chunks you have to compare. Now I have taken only 3 chunks for this example. So that's why the first element of all these chunks I am comparing. Now tell me which is the smallest one? Which is the smallest? 5, 6, 12. 5. So this 5 you need to store into the output buffer and remove from here. Are you clear? Are you
Yes, sir.
clear?
Clear. Clear.
Yeah, in the next cycle, again first element. Here, this is the first element here. This is the first element, and this is the first element. Compare 10, 6, 12. 10, 6, 12. Which is the smallest?
6.
6 is the smallest. Yes, you remove here and put it into the buffer 6. Again, first elements. So what are the first elements? 10, 7, 12. Are you clear? Which is the smallest?
Yes, sir. 7.
7. That 7 is you have to store in the buffer. So now here one buffer is over. Are you clear? Then this buffer again you need to add, but one buffer is over. Clear? Hello? Hello?
Yes, sir.
Yes, sir.
Now again we need to select first elements. 10, 23, 12, which is the smallest? 10, 23, 12, which is the smallest?
Yes, sir.
10 is the smallest. Then 10 is stored into the next buffer. The 10 is stored. Are you clear?
Yes, sir.
Yes, sir.
Are you clear? Yeah. Again, we need to compare first element of all these chunks. 15, 23, 12. Which is the smallest?
12.
12 is stored into the buffer. Yes, buffer. 12 is stored into the buffer. Again, 15, 23, 18. Which is the smallest?
15.
15. Then that is stored into the buffer. Yes, this buffer also full. Okay. Now we have 23. Only two input chunks are there. If you want to add another chunk, yes, you can add. Here I am adding another chunk. That means next following chunk. Like that, we data is more. You can add once the one chunk is empty, then you add one more chunk. After chunk empty, then you need to work out only within those two chunks or one chunk. Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Are you clear?
Yes, sir.
Yeah, I'm having one chunk, that's why I added. Now again, you compare first element 17, 23, 18. Which is the smallest?
17.
17, 23, 18. Which is the smallest? 17. Then
17,
you add that into the buffer. 17 you add it into the buffer. Then again, compare first elements of these three chunks, 25, 23, 18. Which is the smallest?
18.
18, sir.
25, 23, 18. 18. Then you store into the buffer, shift into the buffer. Then compare 25, 23, 20. Which is the smallest?
20.
20, sir.
20. You store 20 into the buffer. Now one chunk is over. If you have any chunk, then you can add. If you don't have, you can compare only these within these two chunks only. If I don't have any other chunk, then I am taking only these two chunks for sorting. 25 and 23. Which is the smallest?
So
25, 23. Which is the smallest? 23. Yes, you have
23.
stored 23 into the output buffer. Yeah. Next, only 25 is there. 25 will be added here. Next, 27 will be added here. So this is the three chunks. It is over. There is no any other data. Then we are sorted. Now understood the multi-M-way sorting mechanism?
Yes, sir.
Multi-way external. Very simple. Okay, two-way sorting and multi-way sorting. In a two-way sorting, just we need to take only two input chunks and we need to have two levels. But in a multi-way sorting, here we can use a number of chunks at a time, but every time we are going to fill with only one output buffer. But there you can have two output buffers. But here we have only one output buffer. Always we need to take first element of the every chunk and compare and sort it and produce that minimum element into the output buffer parallelly. Once the chunk is empty, then you can take next following chunk until unless all the chunks are going to finish. Once the chunks is finished, remaining chunks you can use for this sorting mechanism. Are you clear?
Yes, sir.
Are you
Clear.
clear this?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
Yeah. Yeah. The fourth unit, as per this fourth unit syllabus is completed. If you want, I will share the syllabus once. Then next class onwards, we will start the fifth unit. Just I'm going to read the fourth unit syllabus. Yeah. Please check this fourth unit syllabus. Just I am reading. Graphs, graph implementation methods, graph traversal methods over, and sorting, heap sort, external sort, model for external sorting, and merge sort. The merge sort is they are given last, but anyway your merge sort we need to use in the external sorting. The model, what are the models? Two-way external sorting and M-way external sorting. That is the model. Don't confuse. Okay. This is sorting. This is fourth unit. Is it clear? Hello.
Yes, sir.
Yes,
Yeah,
sir.
fourth unit is completed, right? Fourth unit is completed successfully, correct?
Yes, sir. Complete.
Our side is over. Only yours are the pending. You please practice, work out. Any doubts or any clarification, you can ask in the next class for the regarding fourth unit. Okay? Is it okay?
Okay, sir.
Yeah. Now coming to the fifth unit, we will start fifth unit. If you don't have any doubts in the next class, we will start the fifth unit from the next class onwards. Here, this fifth unit is also very simple. They are given very small syllabus actually. The pattern matching algorithm, brute force, Bayer-Murray, and North Maris-Pratt algorithm. Three algorithms they are given. Pattern matching, very important actually. This pattern matching. And nowadays we are using most of the cases only the pattern matching. Based on the pattern matching algorithms, we are solving so many problems. So that please concentrate this pattern matching algorithm. Very easy and important. And if you understand, it is very easy. Otherwise, you will feel some complexity. The latter standard tries and compressed tries and suffix tries are there. This is also very important. We will discuss. Don't worry, I will complete the syllabus within the given prescribed time. And if you are having any doubts and any clarification, also you can ask. Okay? Is it fine?
Yes, sir.
Yeah. Uh, Now, do you have any doubts regarding this fourth unit till now?
No, sir.
No. Okay, good. Please try